Hi everyone, welcome to our Stencila community call for the month of September. So for today, we're going to show you a couple of demos. Ben will be showing his work on the execution engines in our schema and encoda projects, as well as give an introduction to semantic analysis. And Nakomi will jump in and discuss how we generate structured HTML with encoda. And that's tied into the work that we've done with Thema, which styles semantically structured HTML using different themes in CSS. So I'll be going over Thema themes as well as a new project that we're working on, Stencila Open. So I'm going to pass it to Ben.
Yeah, thanks. I'll just talk about the slide and then I'll take over with the screen share. But essentially, there's a few tools out there that allow you to create a document and execute parts of it. But we don't really have something that's simple to get up and running and just well integrated into the Stencila environment and does the things that we want to do in terms of being able to take a document and analyze it and put it online, and being able to execute both online and from a command line and so on. So we've just done some work on creating engines which will, what we call execution engines, which will execute a given document. And we can take a document that's in JSON format that has either JavaScript, Python, or R code and execute it in one of these three interpreters that we've created. So the way that they're used is fairly similar. So this is just something for JavaScript, an example of calling it from the command line. We can do Stencila execute a document and pass in a couple of parameters. For Python, again, this is how you'd execute that same document from a command line, and would only execute the Python piece of the code in there. And for R, you can call it with an R function to execute a particular document, passing in parameters. So this is a bit hand wavy for now, but I just wanted to show that we have sort of three engines, and they all sort of work in the same way, being able to execute a document. So I'll take over with a screen share now, and I'll show everyone a sort of flow of how to take a document and create it and then convert it to a different format and execute it. So you guys should be able to see my screen in a Visual Studio window there. So the flow that I'm demoing is being able to take create a document in Markdown, convert it to a Word document, and then be able to edit the Word document and then re-execute that Word document and have it go back into Word. So not having to go back and forth to Markdown to make changes to code. The idea being that you as a data scientist or a researcher would be able to create a document with some code, convert it to Word for someone else to make comments on or update, and they'd be able to rerun the document and keep it executable without having to understand executable documents at all. So as I said, the first step in this case is a Markdown document, but of course we would like to be able to use any number of formats to create the initial document. So just in this case, it's Markdown. So this is my intro to data science, and throughout it we've got a code chunk which is executing some Python code, and I'll show you the output in a little bit. But this starts by just taking some, just graphing some random data with a matplot using matplotlib, and then we have another code chunk which gets the current time, and then it outputs it. And the first step of this is to use our encoder to convert this Markdown into a JSON file. So this is a structured JSON that's pulled out all this Markdown information. and added sort of tags around it. So you can see here we've got the heading still, data, and it's converted these to code chunks. So this is not too important, but at this stage, it's just the intermediary format that we need to execute. And I have here, and what I've also done is taken this and executed it and turned it into a Word document, which I have open over here. Just a second. So can everyone see that Word document there? Yeah, cool. So this is it, converted directly to Word. And so it's executed our code to build the plots. So this was run inside Python, and we get the output in here, plus some of the other output that Python's giving us. And then a random number which I put in, which should hopefully change when I re-execute this. It's random though, so I can't guarantee that. And here's the current time of the last time I executed this document, about half an hour ago. So I've made this document, I've executed it, and I want to be able to give this to a reviewer who can then make changes and possibly execute it again. So let's say, you now know data science. That's not really true. You now know some data science, because I'm sure there's more to it than just generating random information. So I will save that and close this. And I'll just jump into a terminal and just re-execute it. So what I've done here is just link a bunch of different tools together. So this is converting from the docx back to JSON, re-executing it in Python, and then taking that JSON back to docx. And at this stage, as I said, there's lots of different tools that I've linked together, but our plan is to have this all integrated, so you can just take a docx and say, I want to be able to re-execute that without having to do all this sort of back and forth. It'll happen automatically in the background. So yeah, that's run, converted back to JSON, rerun the docx, and this should have changed. So there we are, there's my introduction to data science there again. These plots might have changed, I'm not sure, but let's look at this random number. 4, that's good. That was lucky. If it was 65 again, I'd be in trouble. And it's updated this to be the current time, and you now know some data science, so it's retained my changes as well. So that's just a really simple example of how you don't need to know a specific executable document format to be able to go and make content changes to the code as a reviewer. So to carry on from that, I'd just like to talk about some of the analysis that we're doing on the code as part of this. So I've got a little bit of a different document here, just to talk about some of these features. So we can define parameters as part of a document. So you saw on the slide, when we were executing a document, we were passing parameters on the command line. So this allows us to collect information on the command line and use it throughout the code. So in this document, I've defined a start val parameter, which is an integer. And what that means is that when this gets executed, the executor will make sure that that parameter has been passed in somewhere, and then it will be available to use throughout these code chunks. So here I've got a code chunk in Python. It's the same as what I showed before, just rendering some matplot stuff. And it's been analyzed, and we can see it's created a few of these properties here. So one thing it does is, in this piece of code, we're assigning a variable called data somewhere. And this is down somewhere in here. Yeah, so yeah, we're assigning a variable called data. Oh, just missed it. But what that means is that we know, from this piece of code, we have a variable called data, and we can go down to the next piece of code, and we can see that it uses a variable called data, which means we have this link between them. So we can know things like, if this code chunk gets re-executed, then this data might change, and therefore we should re-execute this code chunk because it depends on this variable called data, which was set before. We're doing other things like checking the imports that we use, so we can see what potentially third-party libraries are being used here, and when we set up an environment, we would know that these need to be installed in that environment. We do other things like seeing what functions a variable declares. What variables a code chunk declares, as well as what functions it declares. So this is declaring a variable called finishVal. This code chunk here is declaring a variable called getRandomNumbers, and we can see what kind of parameters this function uses, which will allow us to do things like extract functions from code chunks and make a nice interface, for example, to see what parameters need to be provided by the user. So the next cool kind of thing that we're doing is looking at what files a piece of code will read. So this one opens file.csv and reads it. So we add to this reads array here that we're using file.csv, and that will allow us to collect up related files to your code and bundle it together. We can see it also writes out to an output file, and we know that's a write, so we don't bother collecting that file up. So that was all Python code, but we do the same sort of analysis on JavaScript and R. I don't have any R examples in here, but for JavaScript, you can see where we know that we're declaring a function called load content and declaring a variable. And we can see what imports we're using in JavaScript as well. So this is importing something called package, and so we know that would need to be in an environment. And again, we got this flow-on effect where this piece of code declares a variable called b, and this piece uses that variable b, and so we know there's some kind of dependence between them. So yeah, that's just a basic intro of how we got a nice simple execution environment and some of the code analysis that we're doing. And so I'd like to just pass on to Nakomi here. He's going to talk a little bit more about those code analysis implications, as well as about some of the work he's been doing.
Yeah, I didn't really have a lot to add over and above what you said. I think that, yeah, there's a couple of, just to reiterate what you did say, there's a couple of aspects to that semantic analysis that we haven't implemented, or flow-on effects that we haven't implemented yet, but which we're excited about. So having the ability to know what variables are set and are assigned or declared and assigned and used in various code chunks allows us to do the dependency analysis and have reactive documents, which we've always set out to achieve. So it does that, and as you said, having the imports enables us to do the sort of thing that we were doing with our Doctor tool for building Docker images from the code. So we want to allow users to be able to explicitly declare what packages they're using and build their Docker image or Nix environment, but this code analysis allows a really easy step into that by automating that for users and getting them started. And then, as you said, being able to detect which files are read allows us to bundle up and make sure that a document that we're bundling up is completely reproducible, has all the assets that you need, but also that allows us some reactivity too. So you can imagine having a CSV file which is read by a code chunk and using file watching detection libraries, we can react to changes in your CSV file and update your executable document based on those changes. Or you might have a stream of data coming in that's getting constantly updated, and you'd have your executable document running and updating in response to that. So yeah, all those things we've just really been working on getting the infrastructure there set up and doing that code analysis, and looking forward to actually implementing some of that reactivity. I'm going to hand back to Jacqueline now, if that's okay, because my demo is still in progress.
All right, can everyone see my screen? Okay. All right, so you can find the projects that Ben and Nakomi just talked about on our GitHub repos. So that was Schema and Encoda. Now I'll talk about Thema and open up some of the themes that we've been working on. So using the structured semantic output from Encoda, when we take different formats, for example, a JATS article, we're able to style these different articles in various themes. So we've been working on, we have our own Stencila theme, an eLife theme, as well as one for the Nature magazine and the Public Library of Science. And one key aspect we've been working on is the ability to create different references in various formats, for example, MLA or even journal-specific reference formats using the same markup. So this is an example of the microdata that we're using following either schema.org or our Stencila schema. So that's how it looks in our Public Library of Science one, and this is our nature theme. Okay, and how it looks like in eLife. All right. The other project that we've been working on is Stencila Open. So this combines the three projects we just talked about, Schema, Encoda, and Thema, into a tool that lets researchers publish their articles in formats that are familiar to their managers. So for example, one might want to take an IPy notebook or a markdown file and then convert that into an HTML output or a Word file that their manager can open and edit. So I'll be showing some of the mockups. So this is a landing page that we're starting with, as well as some information on how users' data will be used when they upload files, since we'll be using that information for debugging purposes if there's any errors when converting, so that we can improve our Encoda. Also some more information on supported formats, which includes the different file types, as well as sources, including GitHub, Google Docs, or articles on eLife or Public Library of Science. This is an example of a fatal error message that we might show. And another aspect we've been playing with is where and how to show warnings. So this is one example of showing warnings in the bottom, and also a feedback button to collect feedback from users after converting a file. So it might look something like this. Also, we plan to include a public share link with a unique ID so that people can share this, this preprint essentially. And users would be able to download the files into the different formats that are converted using Encoda and Schema. And lastly, this is an example of our feedback form. Okay. And I think that is the end of what I had to share. Would anyone like to add anything else?
Yeah, I'm ready now. So I'll share my screen and show some of the things I wanted to talk around semantic HTML. So yeah, I was just going to talk a little bit around the work that we've been doing on JSON LD and semantic HTML. So as Jacqueline was saying, we've been developing Encoder, and there's a lot of code here in my Visual Studio share, and I won't go into the details here, but one of the things we have been doing is being able to fetch existing articles from publishers such as eLife and PLOS. And this example here, if you look in my console, I don't know if that's big enough, but you can see that we're converting an eLife URL to HTML, and in the second run, I converted to JSON LD. And so these are the output files that we get. So the JSON LD file is very similar to the JSON that Ben was showing us, with the full document there, with the authors, their affiliations and given names. So structured data which conforms to JSON LD and schema.org structure. And we're taking the similar approach with when we generate HTML. So when we generate the HTML, we're outputting the whole content of the article, but we're also using microdata to transfer the structure that we had in the document across into the things like the citations. So here we have the references for this HTML document that I'll show you. And you can see that each reference is a creative work, a schema.org creative work, and these item type and item prop attributes are defined in the microdata standard as a way of making the document machine readable. So if I take that HTML now and copy it into Google's structured data testing tool, you can see this is that entire HTML that I've copied in, the eLife article, and on the right-hand side we see how the Google web crawler would interpret this. So Google's web crawler will detect both JSON LD and microdata in the document, and you can see that when we've done that, we've got this article that it's passing out of the microdata in the HTML, giving the authors and the article title, and then a whole lot of citations that this document includes. So really emphasizing the linked data aspect of this, and the semantic structure of the document being able to link through to other structured documents. Let me just show you the actual document. Well, before I do that, the other thing I just had ready on my command line here at the bottom was using some of the other codecs that we've been developing, and this one in particular is using Crossref's API. Because we have JSON LD enabled now, we can use the Crossref API, which is able to deliver JSON LD. And here I'm going to search for Watson and Crick's famous paper from Crossref. I'm just putting in a string, which is Watson and Crick 1953, and I'm going to go from Crossref, so Encoder knows what to do with that string, and I'm going to just output it to the console as YAML. This takes a little while, just mainly because I'm running it on uncompiled TypeScript, so it's taking a little while, but in production it runs a lot quicker. But also because it's going and fetching the paper from Crossref. And so you can see there we've got the structured data that came to us in JSON LD, but which we've converted to YAML. And we could, I'm not sure if this will work, but let me try it. We could do the same with HTML, say. Again, this will take a little while just because I'm running TypeScript code, but the HTTP fetcher here has some caching, so If there's caching headers set, then we're not actually going and refetching the data, it's just using the previous run. So. Right, so there we've taken that same structured data on Watson Crick's paper and we've encoded it as HTML. And in this case, because it's a creative work, it doesn't have any content, we've only got the title, we only have it in there with the item prop headline set. Yeah, and then just to give you finally the article that I showed you earlier on. So I was showing you the raw HTML, and here's the actual article with the Stencila theme that Jacqueline showed you. Yeah, so that's the work that we're doing towards making the documents not only look good, so the rendered HTML not only look good with the themes that Jacqueline was showing you, but also be machine readable and yeah, more discoverable because of that.
Okay, thank you. That's the end of our updates. So we have some links on our last slide, and we'll share this on our Stencila Slides repo and in a blog post update. You can sign up to become a Stencila Hub beta tester and hopefully a tester for our new Stencila Open project. And you can send us ideas, examples, bug reports, documentation, questions on any of our repos at github.com/Stencila. Thank you.